Welcome and thank you to everybody for joining us today. I'm Jack Zemlicka, Managing Editor of Strip Till Farmer, and today's live webinar event will explore the opportunities and practical applications of sensing technology in strip till. And today's event is brought to you and other pre-registrants free, courtesy of TopCon Agriculture. To turn information into action, farmers have to decode and process the mountain of gigabytes they've pulled from their farm, assign meaning to it, and make appropriate and timely management decisions. Crop sensing technology is evolving to meet both those challenges. By no means a new technology, remote sensors, usually affixed to sprayers and side dress machines, collect and immediately use real-time data, giving operators the ability to have tailored nitrogen prescriptions for crops before it's too late. Sensing technology and strip till are a promising pairing, but what are the opportunities and obstacles to adoption and ultimately a more targeted, field-tested approach to nutrient application? During today's live webinar event, sponsored by TopCon Agriculture, Dr. Ray Acevedo expands on accuracy of fertilizer application aided by advancements of sensing technology, to include autonomous vehicles and machine vision in strip till systems. So before we begin today, just a couple of quick housekeeping items. If for any reason your internet connection or even our connection should happen to fail at some point and it looks like the webinar has been interrupted, you can go back to the email you received earlier telling you how to join the webinar and re-enter the program that way. Also on your screen, there's an arrow you can click on that will open up a question field and allow you to submit questions at any time during the presentation. Time permitting, we'll look to answer as many of those submissions as possible following the presentation. If we don't get to all the questions, we'll make sure to get them to Ray to respond, and we will also be posting the archive video replay of the webinar so you can go back and revisit the program simply by logging into the site. So with that, I'd like to turn things over to Ray. Good morning, Ray, and thanks again for joining us today.
Thank you, Jack. You guys all hear me just fine?
Yep.
Yep. All right. Well, fantastic. Well, I sure am excited to be here this morning to talk to you guys about sensor technologies and nutrient management. My background is in soil fertility, where I got my PhD at Kansas State University under Dr. David Mingle, and we did extensive amount of work dealing with optical sensor technologies such as Green Seeker, Ag Leader, also TopCon Crop Specs, and then trying to create nitrogen recommendation algorithms to where these sensor technologies can provide you a variable rate nitrogen recommendation on the go. And so getting into our presentation today, I wanted to give you a nice overview of what sensor technologies are available, what can they do for you today in your strip till system, and then at the same time, what's the constraints and where are we looking at for tomorrow? Is it time to adopt now, or is it something to consider in the future? So looking at agriculture today and why optical sensor technologies are so important, and when we're looking at developing these technologies, the matters that we have to consider. We have diverse cropping systems when we're trying to develop optical sensor technologies, whether we're here in Kansas or in the I-States or in Wisconsin or anywhere across the Midwest or the globe. There's many approaches to farm management that can be used to optimize production within a local environment. Those are kind of the little cues that an human agronomist develops over time after working in a farm for a considerable amount of their life. And then what this requires of our optical sensor technology development is that it requires it to be modular. It has to be able to adapt to the specific cropping system it's being applied to, whether it's strip till, no-till, ridge till. There's a number of different types of tillage programs and management programs that these sensor technologies will have to be able to adapt to. And one of the reasons why there's been so much interest in optical sensor technologies or in sensor technology as a whole in precision agriculture is the increasing input costs and how they're creating tighter margins, making it more difficult to be profitable on the farm. And if we're just looking at it from an agronomist standpoint and dealing with technologies, it really requires us as nutrient management specialists to have very acute knowledge of the nutrient variability that we see on your farm. And then what happens then is we have to be able to make nutrient recommendations that are just the right rate applied at the right time in order to help reduce our input costs without sacrificing yield, which ultimately will improve profit per acre. So a little bit of housekeeping, I always like going back to some core soil fertility when we're dealing with nutrient management, whether we have sensor technologies or not. We have to really start looking at what data do we need to collect to make informed decisions. Informed decisions are key to improving profitability in nutrient management, whether you're in strip till, no-till, or ridge till. And so if we start to look at nutrient management, I thought a rather eloquent way that is put, giving credit to Brian Ornell with this ladder approach, was this looking at nutrient management as a stepping stone type ladder. So we have to start at the bottom and work our way up. We're never going to get to the point, or we just aren't yet to the point with sensor technologies to where you don't have to soil sample. It's still a highly recommended practice that can really improve the quality of your nutrient management program. And so if we look at this, what are some of the nutrient management items that we should consider in prioritized order? So if we look at the bottom of the ladder, the first thing we should probably consider is soil pH. And the reason for this is that soil pH is one of the most nutrient limiting factors in the soil. If our soil does not have the appropriate pH levels, it can reduce the availability of nitrogen, phosphorus, potassium, and on the whole, bring down your entire nutrient management program and reduce profitability. There's a substantial amount of research out there done by universities that show simple applications of lime, keeping that pH at the right zone can greatly improve the profitability on your farm. And once we have our pH taken care of, then we can start to consider our phosphorus and potassium. These non-mobile nutrients in the soil optimally take either grid soil sampling or soil sampling by zone, or even a composite sample can really help you get you on the right track on what you need, what you have for potassium or phosphorus levels, and if you need to make any additional applications in order to ensure your P and K is the right spot for optimizing yield. And once you have your P and K taken care of, you can start considering your nitrogen and sulfur. And the reason why, we have this kind of approach, usually people jump right into nitrogen and sulfur, just nitrogen alone. And with me and a number of my colleagues who are nitrogen specialists, we really love to just jump right into nitrogen. But the deal is, if our soil pH and P and K are not in the right spot, no matter how good we make that nitrogen program, it's always going to be lagging in yield and profitability because the lower rings of the ladder haven't been taken care of yet. And so whether we use soil sampling, depending on the kind of environment that you have, or optical sensor technologies, and this is where they really thrive as helping with nitrogen management, nitrogen prescriptions. When we have that taken care of, we can start going up and considering our secondary and micronutrients. Now, getting into what's at the top of the ladder is we have our in-season crop response. And so this is like during this season, we're collecting optical sensor data, whether from drones, satellites, crop specs on a sprayer. Is that what this does for you is that we're catching in-field variability of the crop's response to soil by weather interactions. Just like we've been seeing a lot of rainfall in the northern states this year, is that drastically changes how we're going to do our nitrogen management. Excuse me. And what we're going to see for in-season nitrogen losses. And so if we were just doing a pre-applied program, we would never be able to take into consideration what's happening in season. And so by utilizing optical sensor technologies, we can read what the crop is telling us and develop multiple nutrients variable rate applications. And this is where we can really start to hone into improving profit per acre on the farm. And so if we're considering sensor technologies, if you haven't gotten to the point of making sure your pH and P and K are in the right order, that you're actually not going to see as much profitability from newer sensor technology. So we can never actually remove this core agronomy, core soil fertility from the mix. We always have to have that as the foundation of any nutrient management program. So let's start getting into some of the science behind why optical sensor technologies are so important to nutrient management. Why are they so usable? Why does an agronomist like myself really get excited about dealing with sensor technologies? So if we look at it from a basic point of view, plants are a visual communicator. They speak to us with wavelengths of light. They don't speak to us through sound like I am doing with you on this webinar today, through light. And every wavelength of light is a different dialect of their language. And it can inform us of the different types of stresses that they're experiencing and help us decide on what we should do to help them. So if we start actually looking at this, what we call the electromagnetic spectrum, all the different types of wavelengths of light that are going out, we see as humans as what's called the visible spectrum. So this is our red, green, blues, oranges, yellows, purples. And just from that alone, we can derive a lot of issues, what's happening to the plant. But when we start to incorporate optical sensor technologies, it greatly improves our own human spectral resolution of what we can see in light and what the crop is saying is wrong. This is where I'm sure a number of you have heard of, like near infrared light, is that where it strongly interacts with plant cells and actually gives us a good gauge of plant biomass, how big that plant factory is operating at. But then when we look at our reds and red edge lights, that's commonly used, say, from satellite technology or green seeker or crop spec, is what this does is start giving us a gauge of how good photosynthesis is being conducted. Since red light is heavily absorbed by chlorophyll, it kind of gives us a gauge of photosynthetic capacity. And so between red light, red edge, and near infrared, we can start to see how big that plant factory is and how efficient it's operating at to produce yield. And so when we start to bring this in together with core agronomy, core soil fertility, and crop physiology, let's start looking at some real world pictures on these different types of stress that we've been working on for the past number of decades, even 100 years as an agronomist doing research, trying to understand what the plant is telling us. This is an example picture from the research that we did back in my K-State days with Dr. David Mingle, over here in Rossville, Kansas, on some of our corn plots. And we can easily identify this as nitrogen stress. We can see from the yellowing, from the chlorotic activity that's going on, that's clearly in a V shape along the midrib of the leaf. This is your typical nitrogen stress. And this is happening because the nitrogen is being translocated from the lower leaves all the way up to the upper leaves to support photosynthetic capacity in the upper part of the canopy where the most of light interception would take place. So we clearly got nitrogen stress occurring on this plant. But then when we can go into some of our other corn at earlier growth stages, and we can see from the bottom all the way up, the plant is looking nice dark green and is clearly healthy and has enough nitrogen in the soil system for it to be growing appropriately right now. But then we can start utilizing these optical sensor technologies to start getting a much broader view of what the plant is telling us is going on with it in the environment. So if we look at this particular field, you don't have to be an agronomist to be able to see that we have a number of different issues going on in this field. This is actually a drone image that was taken not too far from Rossville, Kansas at one of our experiment stations. And we can see all sorts of variability here. This is one of the reasons why drone technology was so captivating, so to speak, say 5 years ago when it really started entering into agriculture. Just having this bird's eye view of the field tells us, it shows us all this variability. But now when we start looking at this as we move forward from 5 years ago and we start looking at data integration and making our machine systems more intelligent and being able to think like a human agronomist, let's break this down in simple human terms of these different data layers, different sensor technologies, and focus in on like one of these key areas of variability in this field. So if we're thinking about it as these plants as visual communicators, they're actually informing us of the different types of soil variability that's happening in this field. And so if we actually break them apart into soil texture, RGB imagery, thermal imagery, and NDRE, or what you can kind of consider your NDVI that uses red edge light, is actually showing us these different types of soil variability that we indeed, in fact, confirmed using soil sensing technology provided to us by various technologies. And so utilizing electrical conductivity, we look at the soil texture within the first foot and the first 3 feet of the soil profile on the z-axis and across the x and y across the field. We can clearly see huge variability in soil texture. That is directly correlated to what the imagery, the optical sensor data is actually showing us in this field. So what does this actually mean agronomically? So these deep reds and yellow areas here is actually sandier soils all the way through the 3 feet of the soil profile that we measured. But when we get into our greens and our blue areas of the field, these are our more loamy, silt loam type soils. When we're looking at the agronomics behind this, the soil fertility, the sandier soils are going to have a lower water holding capacity. And in addition, we're also going to suffer more nutrient losses such as nitrate leaching losses. But when we get into our loamy and silt loam soils, we're going to have a lot higher water holding capacity. They're going to have a lot higher water availability. And on this particular year that this data set was collected, it was more of a drouthy year. And despite being an irrigated field, there are still plenty of times where there wasn't enough water available. And when we were looking at a standard RGB image, what we see in the visible spectrum here as humans, we clearly see this variability emulated by the soil on this image. But then when we start looking at specific optical sensor data sets like thermal imagery, where the imagery is actually a direct representation of thermal signatures, how much heat is coming off the plant, we can see in this blue section, based on the scale, this area of the plant where we actually have more loam soils, it is running cooler. It is a lower temperature, and this would make sense agronomically because we would have a higher water availability in these loamy sections of the soil. But when we get into where the deep sands are, we can clearly see that the thermal temperatures of the soybean plants are as considerably higher. The roots are not able to access near as much water. There just isn't enough water available. So during evapotranspiration, during transpiration pull, the plant can't keep itself as cool. So we see that direct response in the thermal imagery. But then when we look at something like your NDVIs or NDRE, where we start looking at direct effects of plant biomass and photosynthetic capacity, we can also see that same correlation between the sandy areas of the soil and the loam areas of the soil in dealing with plant productivity. These areas in the blue are highly productive soybean plants, large amount of biomass, they're getting plenty of water, and we have good photosynthetic activity. You're pretty well guaranteed these areas where you see in the blue, you're going to have substantially higher yields. Whereas when we get into those sandy areas that we've confirmed with soil sensor technology, is that we can see lower biomass, we can see less photosynthesis occurring. We can expect that we're going to have a yield reduction if we do not actually start getting more moisture on these soybean plants. So these are some of the very most popular types of sensor technologies that's currently available today. That is basically gold to the agronomist, to the soil fertility professional out there in most farms, because it kind of gives you a real well-rounded perspective on how the soil and the plant are interacting within any given in-season environmental interaction. So let's start to break this down on like how sensor technologies have been developed. So it's not like a black box to you. It's one thing for some guy to come up to your field and he's trying to sell you a set of some sort of optical sensors of some kind or a drone and just says that, oh, it can help your farm. But can it really? And if so, how was it actually developed? So we start breaking down dealing with agronomists, optics, and the algorithms that they have developed to make improvements on your farm. You know, as from an agronomist perspective here, it was only natural that we were gravitating towards optical sensors right out of the gate. One of the first things that we tried to engineer to make improvements to the farm. And why is that? We go out there and scout fields, and one of the main things that we heavily rely on in crop scouting is vision. One of our first bases for making assessments of crop health is basically based on what we see. And then we start thinking about the different interactions with the environment. And so what happens is there's a lot of good agronomists in the field utilize algorithms they've developed themselves to interpret what they see as crop stress. And so they start to look at what's the severity of the crop stress. They make that determination. And then they start to decide, will this severity of crop stress impact yield? And then, of course, as all agronomists are called to the field to do, is create a prescription for the farmer to resolve that stress observed. And with so much focus being on nitrogen these days, because this is extreme variability observed from year to year and depending on soil type and being extremely costly nowadays, is one of the primary areas of focus for a lot of agronomists and the optical sensors that have been developed. So what I would like to do right now is actually go into what I call the agronomist nitrogen recommendation algorithm. And there's a number of optical sensor technologies when they're actually developed behind their core programming. These are some of the steps, or they should at least utilize these kind of steps in order to assess whether or not your field is experiencing nitrogen stress and if a recommendation should be made. So let's go through this in a step-by-step approach. So if I was in the field with you scouting, one of the first things I would do is inquire about the average grain yield you have observed in this field from year to year. And what is your current yield goal? Why is that? Well, if we think about it, final grain yield is the end result of all the interactions observed between crop, soil, and weather. And so by making this question and knowing that you guys know your fields, you understand what kind of yields you're getting, and it's reliable data that I'm getting from you, this really helps me as an agronomist to calibrate for the yield behavioral changes that is observed across your farm, across your fields, and then be able to assess what are the impacts of the variety of weather conditions in response to soil. Then what I do as we're walking around is I utilize remote sensing through my own vision, our own human optical sensors, and start to make the determination, do I visually see nitrogen stress occurring right now? And then after that, I start to consider the soil type, soil textural changes, soil test analysis data, if available throughout this field, in combination with local weather patterns, heavily precipitation. And what this does is this helps me as an agronomist determine the nitrogen loss characteristics for your field. Just like what we were showing dealing with that soil texture data and that imagery in the previous slides, starting to put together what we would see for loss and how that's going to impact nitrogen use efficiency for this field. So then I start to also look at crop physiology, which is we start to look at considering the current growth stage of the crop. Why is that? Because different growth stages are linked with specific yield determining factors. So if we start looking at your corn at V6 to V12, I'm going to be very attentive to making sure that your corn crop is not nitrogen stressed during that period. Why is that? Because ear size determination takes place. And so if we actually stress your corn crop during that ear size determining period between V6 and V12, that is permanent yield loss that will take place. And that brings us into our next area. And so if we start to consider the current health of the crop in combination with the growth stage, and if it's a yield determining factor time, I can start to determine if I can make a yield recovery by making a nitrogen application, or I can start to determine if this is permanent yield loss. So for example, say we come in at V14 and it's been clearly stressed and it was stressed through V10 through V12, I know that odds are pretty good that we have suffered permanent yield loss, and I shouldn't be throwing down that additional 150 pounds of N, because it's never going to be improving your yield and improving your profitability. I'd be better off pulling that nitrogen recommendation back and only applying and for what we can actually truly obtain for yield. And so this brings us, after bringing this all together in these number of high-level steps, is that your agronomist will make you your final nitrogen recommendation. And so what's the significance of optical sensor technologies, and that the algorithms behind them that has been developed by a number of different universities and different companies in collaboration, is that they start to bring all these steps together and apply agronomist logic, good science behind making true variable rate nitrogen recommendations on the go, addressing what the crop needs exactly at the right time, and then also at the right place. So that 4R concept that I'm sure a number of you have seen already. So let me give you some examples. Now that we've been talking about, science and, all that theoretical stuff, let's talk about some actual real world things. And so dealing with the TopCon crop specs and how they help agronomists on the farm, let's start looking at this. Crop specs are an active optical sensor technology. They're the direct competition to something like Trimble GreenSeeker or Ag Leader, and what they have, but they also work really well in conjunction with satellite technology and drone technology. And what they do is they help provide us a whole picture of the variability throughout the entire field, of areas of the field that clearly have plenty of nitrogen, other areas that may be having nitrogen stress, and we should be making a nitrogen application. And the great thing is that it really improves the time efficiency for finding that nitrogen stress. And probably the thing I have to stress as being incredibly critical is that it's consistent and repeatable data. And so we can build in that agronomist logic into this thing, built by agronomists who are nitrogen specialists, and it can give you reliable results every time to generate a variable rate application and put the nitrogen where it needs it. And so if we look at this, then we start making much better informed decisions, putting the nitrogen where it needs to go based on the variability of what's happening this season. What happened last season has absolutely no bearing on what we should be doing this year. And I've run across so many farmers these days where they just always put on the flat rate that they always done before, because, to their credit, and just like me, all I want to go out there and do is farm. I want to hit the easy button. These are what these kind of sensor technologies being developed by agronomists, that's their direct intention, is making to where you can focus on farming and at the same time put technology to work backed by good agronomic sciences to improving profit per acre. Okay, so that all sounds well and good. So Dr. Ray, tell me about why this technology isn't just going gangbusters in farming today. And based on what I'm saying for some participants here that I definitely know among the audience, glad to see you guys are there. I'm sure you can dive into why this is the case, as many of us have had experience with. Let's go into some of that, because it's actually pretty important on what's changing to this day and what's coming in the coming years that will actually enable optical sensor technologies on the farm. One of the first things was dealing with the actual limitation in in-field computing power. When you're trying to give on-the-go nitrogen recommendations or put in some sort of sophisticated algorithm developed by an agronomist, there simply wasn't enough compute power on the farm and in the field to actually do this. This is actually changing nowadays. And of course, if we look back, 10 years ago when the GreenSeeker first came out, the TopCon crop spec, there was no cloud or machine-to-machine connectivity. That just didn't happen. Matter of fact, to this day, I'm sure many of you can raise your hand and say, I've had plenty of connectivity issues using Verizon, US Cellular, or whoever you have. That still continues to be a struggle. So what does this do? This limits the scalability of sensor technologies and the value they can bring to your farm. If it's difficult for you to access that data and the direct output it gives you, that nitrogen recommendation, if it's a royal pain for you to get to it, like it was 10 years ago, odds are you're not going to waste your time with it, and neither would I. And one of the things is that's why this has been an issue besides just connectivity, is that we're lacking a unifying platform. When I start to look at, I have my Veris soil sensing data, and then I got my drone imagery, and then I got my active optical sensor data from Crossfex. I would have to put that together all by myself, and I would have to use multiple different types of programs to make these different data layers work together. That was a substantial amount of time investment, and then also required a lot of expertise to make that happen. I'm sure, like most of you out there, you're not going to be a specialist in everything, and neither am I. Some of us are a specialist in GIS type work, doing that kind of computing, and some of us are not. So when dealing with that unifying platform, it's able to, we start thinking about a single software platform, a single machine platform, where it can bring all that optical sensor data, all those other sensor data like Veris or soil moisture, weather data, satellite data, brings it all together in a single location. It will actually make it easier for farmers and agronomists to implement, especially if it's developed on a program that doesn't require you to be a remote sensing and GIS specialist. So start getting into why connectivity and seamless integration is so important and what's changing today that is actually going to enable this technology to improve your strip till system on the farm. We start looking at, I'm going to say specifically what's going on with TopCon and what efforts we're making in that region in collaboration with Kansas State University with the recent partnership they have developed. Let's start going into sensor integration and IoT. You know, for quite a while, IoT was this like, three-letter word that nobody really knew what it meant. And then now, it means Internet of Things. And still to this day, that's kind of like a confusing term. Basically, what Internet of Things means in IoT is just a short change way of saying, we have all these different sensors across the farm. We're going to connect them all together. We're going to unify them on a platform. And so that way we can put all those data layers to work to make informed decisions on the farm. And so if we start looking at this on a piece by piece level, first dealing with planting and seeding, dealing with your strip till system, putting the seed exactly where you want it, enabling RTK systems and drone technology to go ahead and actually be able to determine, did you have the right amount of germination? Do you need to replant? Is that seed going where it needs to go? Having that exact, accurate planting population will be the critical foundation of your entire season for improving profitability. Next, we have to start thinking about dealing with growing throughout the season, spraying, making fertilizer applications. Watch a soil fertility guy like myself, this is where I get really excited. We have our drones and our satellites scanning the fields. We have prospects on the tractor making those real-time nitrogen recommendations. And you could be utilizing something like, say, Y-drops and putting that nitrogen right beside the row of the plant where you want it at. But how are you going to know what is the exact rate? What is the right time to apply? This is where that integration of optical sensor technologies will really enable to improve the profitability of the farm through better variable rate applications. And then we start linking it up, bringing that harvest data back into play, that end yield, which changes the entire game of how we develop our farm management systems, because it is that final interaction between soil and weather. This really tells us of a lot of things, what we should be doing in changing our nitrogen management plan. And so if we look at it, basically, I'm sure a number of you have, a truckload of USB sticks, sitting somewhere, in your drawer, still in the cab of the tractor or in the combine. And so dealing with IoT, what's changing the game for it is the automatic streaming of that harvest data, the automatic calibration of that harvest data to where we get good yield data going back to your farm compute system so your agronomist can utilize reliable information to make better variable rate applications for you. And so with these improvements in connectivity and seamless integration is really kind of bringing optical sensor technologies to the forefront of farming that'll make it to where it can be the cornerstone of your crop monitoring program and putting nitrogen on where you need it. And so if we start to bring all these pieces together, we can start to formulate what agronomists would love to, call an agronomic ecosystem, putting all the pieces together, the soils data, the weather data, the harvest data, the as applied data. Did we even put down what we said to put down? Do we anticipate needing to make any other changes? And so when we start doing that, all that money you've already invested in technologies such as variable rate seeding, also in variable rate sprayers, we can actually start to utilize and make that technology pay dividends. But that connectivity, that IoT, to be able to put those optical sensors into play on your farm is a critical piece to where we can finally close the loop and start making informed decisions and actually put all of that university research to work. So diving back into what is more fun, which is dealing with the actual agronomics of sensors. So let's run through another scenario where we start putting these different disciplines together in an agronomic platform that's enabled through IoT. So as many people have seen marketed, as red NDVI as the game changer of life and ag, which is simply not the case. It is a nice single step of a data layer to start seeing what's happening for variability on your farm. And of course, we said that, plants being visual communicators, we obviously see some variability on the close-up area of this field. And so we have to start thinking about, okay, well, what's going on in this? What's the plant actually doing? Well, we start looking at soil variability, and then naturally a soil fertility guy will tell you that soil data is a critical component of everything. We can start to see that we have some pretty serious organic matter differences. Now, I'm sure some of you are chuckling in the back of your mind that, wow, we got, 0.75% to 1.75% organic matter. That's all pretty low. But as a native born Kansan, we start getting pretty excited about our organic matter when it's somewhere around 2%. So we're not necessarily like Iowa, but we're getting there. And so if we look at the impacts of what even just this little bit of an organic matter change would do, we layer those data layers together, just say visually right here, we can see there's actually a direct correlation in our organic matter and what we're seeing actually for crop productivity. This area of the crop is actually greener, clearly has more biomass. So why is that necessarily the case? Well, we start bringing in our soil texture data. On top of that, we can see in these green areas that what that actually signifies is we have a clay lens about 3 feet down. It wasn't very thick. It wasn't even more than a half an inch thick. But what it would do is that clay lens up here would actually hold up all of the nutrients in the soil. Whereas where we get to the heavy sandy areas of the soil where we don't have that clay lens, we had deep nitrate leaching going on. And of course, less water availability. And so throughout that area, we saw a reduction in productivity. We were stressed during V6, stressed all the way through to V12. As you can imagine, we probably suffered permanent yield losses, and we needed to make frequent nitrogen applications over this area. But when we start looking at dealing with that clay lens 3 feet down here, holding up those nutrients, but then at the same time, having more organic matter, and of course, organic matter being the great thing that provides more mineralized N and also makes more water available and holds more water. The cool thing that we saw in this field is that there was actually a subsurface slope dealing with this clay lens, and the nitrate actually moved along that clay lens across the entire field. And so if we were actually looking at this as imagery over time or prospects over time, optical sensor data taken throughout this entire season, you can actually see the nitrogen moving throughout your field, how it's changing, which is an incredibly useful thing. And so by providing the appropriate type of data, putting together these different types of sensor platforms, optical sensors and soil sensors, getting good soil texture maps that are confirmed by your imagery data, we can start to really determine in-field variability, and not only that, determine the cause of them, and how do we apply a variable rate prescription, and most importantly, when is the right time to apply it based on the growth stage of the crop. Now, I had to actually throw something in here a little bit dealing with how we're utilizing optical sensor technologies with crop protection, because one of the things that always bothered me when we were having a great looking crop and our nutrient management program was being managed to a T, somebody would always forget to apply some fungicide. And then, of course, we would have some serious issues. I ask you, looking at this image here, this is dealing with corn, and of course, it was near maturity, it looks brown. Does it really matter if anything's going on at this time or what happened previous to this stage? Well, if we actually start looking at some of the ear size differences that I pulled throughout that field, we actually had different fungicide strips on top of our different nutrient applications, and we can actually see ear size differences in this field. And then we start looking at kernel depth, how well we were filling the grain from the time between R1 all the way up to maturity, up to black layer. I can't stress enough the importance of sustaining photosynthetic capacity all the way through to black layer. Because if when we start actually looking at this, utilizing our optical sensors, utilizing NDVI or NDRE, seeing what we can't see with the human eye, there is still a considerable amount of photosynthetic activity that was taking place where we applied our strips of fungicide. Matter of fact, you can still even see where we had drift from our applications of fungicide. So basically, it was still filling grain all the way up to the bitter end, and there was as much as a 40 bushel difference in our end yields when we, based on where we applied our fungicide and where we didn't. And so that actually, at the end of the day, that was 260 bushel versus 220. And so at the time, the farmer whose field this belonged to was completely happy with their 220 bushel yield. It was right on par with what they normally do. They thought they were doing great until we actually started utilizing our optical sensor technologies to determine, are we optimizing productivity across this field? Even though we're doing our nutrient management right, are we protecting the crop to ensure we maximize profitability? And well, what he found out is in this particular instance, no, we didn't. We probably should have applied fungicide across a lot of different fields within this crop. So when you start thinking about it and asking yourself, should I be considering sensor technologies? Are they ready for me? And where should I start? I strongly suggest looking to companies that have also worked with universities and have university-backed research and developed modular type systems. So basically, what do I mean by that is that, can I put on an optical sensor on my sprayer, or can I buy a drone and just buy that one thing alone, and that one component, that one sensor can operate independently? Basically meaning I don't have to invest $100,000 in some sort of massive IoT system in order to make good, improved nitrogen management decisions or nutrient management decisions. So you'll find that there are differences in companies and what they offer, to where they kind of require you to buy the whole kit and caboodle in order to supposedly make improvements on your farm. But you could pick up different types of optical sensors like Topcon crop specs, where it's just one purchase, and then that you can start putting nitrogen recommendation algorithms developed by agronomists and plan your farm today. And or you can also buy, drone systems with multispectral imagery that's been backed by university algorithms to do the same thing. You don't have to make massive investments all at once. And that's my recommendation to you today, is take a stepping stone approach. Any company that does not offer some sort of product portfolio where you have a stepping stone approach and their staff is fully up to par and knowledgeable on the agronomic impact of their systems, to where you can take one piece at a time, one optical sensor, one soil sensor, and build your way up to a full system. And every time you add that extra little piece to your new farming system, your new number of sensors, is that it's giving you measurable ROI. And then, of course, I don't get excited when a sales guy or some sort of ag tech guy, or any tech guy, matter of fact, spouting off about the different types of engineering specs of an optical sensor or soil sensor. Truth of the matter is, I don't know of too many farmers that really care what kind of wavelengths an optical sensor has. What they really care about is it giving me the information I need to make an actionable recommendation. Is this optical sensor actually giving me a nitrogen output? And has been proven to improve profit per acre on the farm. You should probably just, like, instead of listening to the entire sales spiels, get down to the brass taxes, which is, will this give me a nitrogen recommendation? If they say yes, okay, well, show me what that looks like. Show me these recommendation maps that you've done. Have you done any collaborative research on the farm? And so that brings us to some like different types of active optical sensor technologies, such as Topcon Crosspex is a great place to start. It's a fantastic sensor, has a long range of agronomic research that goes behind it. But then you'll have other fantastic sensor technologies like Varus, dealing with soils, been in play for many decades, well proven by and backed by university research to integrate well for improving your soil fertility program on your farm and your strip till system. Man, it's amazing how fast time flies by, and I can get on my soapbox talking soil fertility and sensors for, well, pretty much an entire day. But with that, I would like to thank you for your time, and I would be happy to entertain any direct questions. And of course, also, if you have any sort of more direct core soil fertility questions, I would love to take any of those questions too. And if I don't honestly know the answer, I'd be happy to refer you to somebody that knows even more than I do. So with that, thank you.
Thanks a lot, Ray. Great information, a lot to digest there, and some good tips, some good advice as well. One of the questions that I had, I guess personally, was I know there has been a lot of evolution with sensing technology, and it seems to be kind of a hot button issue, whether you're talking with service providers or farmers themselves. But what are you seeing from your perspective as I guess the biggest adoption hurdles right now? I know you mentioned that during your presentation, but when you're talking about a strip tiller that maybe has dabbled in some of the sensing technology, or is kind of taking a look at, what's the biggest ROI? Are there things that are standing out that are maybe limiting factors at this point?
Yeah, definitely. That's a very good question, Jack, and a pretty common one. And dealing with that adoption curve and what's limiting it is a pretty popular topic. One that doesn't necessarily have to deal with individual sensors themselves is the fact that there's so many, there's so many different sensors to pick from. Then I just have to call it like I see here. Some of them, in our old soil fertility term of calling things snake oil, right? You'd have a fertility product that came out that says it's basically the silver bullet and it's going to solve all your problems in agriculture. We've been seeing that very same thing dealing with sensor technologies. When the drone technology came out and all the imagery that it brought to bear, there was a number of marketing schemes out there that made it out that with this NDVI from this drone, you can make an amazing nitrogen recommendation map, VRA, that was going to pay dividends easily the first year, when that actually turned out to not be the case. And so there was a lot of people that got burned in that process, and others who saw that happen. And so naturally right now, what I'm seeing across that precision ag space is that most service providers, dealers, and farmers are pretty apprehensive and see a lot of risk when they're looking at adopting a sensor technology. And so right now, when I'm talking with dealers and farmers, they just get down to it and like, okay, well, which one's actually going to help me? And so an easy way to look at this is that, will this technology, can you apply it to multiple things on the farm? So can it help you with your nitrogen, your entire fertility program, nitrogen, sulfur, those kind of things? But then can it also help you with your planting and seeding? Can it also be applied for your protection, And then if you're a diverse operation, what can it do for your cattle, right? And so what I'm getting to there is if you see a sensor technology and they're actually showing you real world results, that's a big thing. They actually have real results that's been conducted by them, and hopefully also a third party like a university that shows actual ROI improvement, and it can be applied to multiple aspects of the farm. Why is that critical to me? Is because the more things it can be applied to on your farm that has been proven, that means the odds are very good that it's going to have a very nice ROI, to where it's actually going to start getting in the green, so to speak, where it pays dividends and actually improves profit per acre on the farm. And another thing is that when I'm looking at sensor technologies, I tell guys, I'm like, hey, whether it's at optical sensors, which I absolutely love, it's a great technology, but unless it can make you money every year, whether it's a drought year, optimum year, or too wet of year, even whether it's fit an extra $40 an acre, or it just made you an extra quarter an acre on those bad years. The point is that it's profitable, and that's actually paid for itself well within the first year. That's another thing that I really kind of look for. Can it pay for itself in the first year? And so if it actually can pay those kind of dividends and it has those proven results, then that may be a good technology to adopt. And I think, the ag space has really started to look at resetting itself and be like, let's bring this back to core Midwestern ag, which is prove to me it works first. Build that trust between that company, that university, and that farmer, showing that you know your stuff, whether it's an agronomist or a sensor, it knows its stuff and it makes you money every year, and you formulate that trust. Right now, I would say that's probably one of our biggest hindrances dealing with adoption of sensor technologies, is that the trust is not there. It seems too much of a black box. Farmers don't understand it, and the very people that are trying to sell it don't understand it themselves. And so that's one of the things that has to be rectified. We have to give confidence to the farmer that this technology works, we have proven results, and we will stand behind it all day long.
And that sounds like it's something that's going to take, kind of a multi-layered investment. You mentioned, obviously with the service provider, education institutions, farmers themselves, and it sounds like it's going to take time. But from your perspective, are we moving in the right direction?
You know what, I think we are. I've been dealing with a number of different universities that are really developing out their extension programs to provide better support when it comes to these kind of precision ag technologies. And then at the same time, whether it's independent consulting agronomists or co-ops or regional sized consulting agronomist companies, and dealers and ag tech dealers, is that I've been seeing a lot more effort in just on the education side, where they're trying to get informed, trying to learn what this technology can do and see it happen for themselves before they even present it to their growers. So there's been a number of presentations that I've done over this past year alone, just dealing with local dealers. They brought in their farmers, and we were out there in the cornfield seeing like prospects go through the field. And I just, we actually scouted the field and did some basic agronomy and why these things make sense. And so I've been seeing a lot more of that these days. And the farmers they're a lot more willing to listen to these, what used to be considered radical notions of making nitrogen applications at V10, 10 leaves on corn. 8 years ago, that was a real struggle. But now we're like, what can we do to improve profit per acre on the farm? And the dealers are like, we want to help you do this. So let's start building up our knowledge base, so we're confident what we're offering you as a sensor technology will actually do that. So I think it's definitely going in the right direction. It's just like you said, Jack, though, it's that it's going to take time.
Great. Well, Ray, again, really appreciate you taking some time with us today, sharing your insight and advice on sensing technology, what we can expect now, kind of where we're going with that. So with that, thanks everyone for joining us today for the program. Just a reminder, again, that today's presentation and audio will be made available on the Strip Till Farmer website. And just a quick reminder here to join us at the 27th Annual National No-Tillage Conference. That's coming up January 8th through the 11th, and it's going to be in Indianapolis. The theme of the 2019 event is Pathways to Higher No-Till Profits, and it'll feature a mix of general sessions, classrooms, and roundtable discussions. You can find more speaker information and the full agenda at notillfarmer.com. Well, on behalf of Dr. Ray Acevedo, Topcon Agriculture, and our entire Strip Till Farmer team, thanks again for joining us today. We'll see you next time.
Thank you.